if it is j plus I, then it is pretty obvious. There is no the exponential time it will reach n, and so yeah.
So it will
So
reduce.
I guess, yeah, this type of problem is quite easy for like for me. Now the main problem which comes with only with like recurrence type, where we'll have to find the recurrence.
Yeah, we'll do that. We'll do that. Okay. So I'll continue sharing my screen. Pooja, thanks for that. If we had seen that I on that day itself, we would have done it, right, Pooja?
Yes.
Yeah. Okay. Great. Okay. So we'll go to the next question. Navika.
Yeah.
Great. So here comes the recurrence relation. Anwar, if you're typing something, can you please mute yourself if you don't mind?
Yeah.
Yeah, I think Sachin, you were telling that you were kind of getting these questions hard, right?
Yeah. Like
Okay.
while evaluating step by step, then the problem will come.
Okay. So how is this big O of n square? Hmm? Sachin, I'm asking you.
Yeah.
How will
So
you find the complexity for this?
like how will we proceed? Like what will be the first step?
Okay. Navika, I think you know this, right? Have you? Do you remember?
Like
Yeah, this is what even I was thinking, but I'm not getting the answer through this. I mean, how are we
like
going to do like the way we did yesterday? R
what?
is equals to 4,
Yeah. This
P is
type.
equals
Like
to 4.
Okay. So that formula, whatever you guys are thinking about, okay, log CR, right? I think what was something? I mean, so I think it was n power, huh?
Yeah, n power.
Yeah, n power log CR. Okay, so this is for increasing function, right? So can you tell me what is the sum for this? Can someone tell me what is the sum of this?
N by 2,
N by
no?
4 plus n by 4, which will be n by 2. What will be in the next iteration?
It's going to be n by 4 into n. Oh, no, sorry. What am I
n
It will
by
become n by
16.
4. No, n by 16. Huh? Like, okay, let's see. So, and this, yeah, here it will be n by 16. You're right. I mean, these two will be n by 16. Correct?
Yeah.
This also n by 16. I am asking about the sum. Sum will be n by
Also
4. Okay. So which is nothing but, basically this is n by 2 power 3. It will be like this. So, which is equal to n by 2 power 2. Navika, you're following what I'm doing?
Yes. So this is a
Okay.
decreasing one, no?
Like, yeah, exactly. This is a decreasing one. So you won't get an exponential thing here. Okay, that's the first thing. And second thing is that so you remember, if it is decreasing thing, then it was something like log based, right?
Yeah.
Okay, this is very similar to our what sort binary search, if you remember. Every time we split into half, correct, guys?
yes.
Okay, but still, why the answer, so it's not going to be exponential. Why the answer is big O of n square? Look at this, Sachin. This
Hmm.
single term is making it big O of n square, nothing
Yeah,
else.
like we are selecting the higher term, like higher function.
Ah, correct. Hey, excuse me, 1 minute, please. I'm getting.
Yeah.
Guys, am I audible?
Yes.
Okay. So yeah, we take the highest term. You are correct. Okay. So I
No,
say, go ahead, go
just,
ahead.
just a second. Like yesterday, when we did such type of questions, so there were these three different formulas, right? One
That's
when
what
we
I
have the same sum for each level. So then it's
correct.
n log n, right? And when it is an increasing one, then as you said, it's the same, n raised to power log base 2.
Hmm.
But there was I think, for decreasing one, what was the
They told that, big of f of n, which
hmm,
still I am not clear about.
each term at a constant.
Wait, it's function of n by c. Okay, look at this. F of n. Okay, that's it. Big of f of n. So which means,
Yeah. And
uh,
in this particular case, it's n square.
huh, correct. So
Highest value, no?
correct.
Okay.
So is that okay? Right?
Yes.
Okay. Wait a second. Wait a second. Wait a second. Wait a second. With you guys, I'm learning a lot. How will we write the complexity as? See, Navika, this is how we write the complexity. You remember? See this.
Yes.
Okay. So that complexity is going to be big of f of n. So
Okay,
the
just a second.
joining thing is going to be the complexity.
Okay. 1 second, huh? I'm just writing down this.
Sure. If you want to take a picture also.
Done, done, done.
So now that we also, I mean, I think Sachin is kind of new for this, right, Sachin?
Yeah, like I have no idea with recursion
Yeah, yeah.
trees.
Don't no, you don't need to have an idea, but you will have an idea. See, you can clearly understand that it is a decreasing function, correct?
Yes.
It is a decreasing, like the total is decreasing at every step, correct?
Yeah.
So if total is decreasing at every step, then the complexity is going to be f of n. So which is this, whatever you have after that. Got the point?
Okay. But let's suppose the term like n square, if we will get something like a constant over there, then will we consider it as a like bigger complexity?
Bro, even this n square is also a constant, right?
N
Means
square is constant.
see, and like what should I say? I'm not able to tell you a exact thing. What should I say here?
Here
Your
n
question is
is
that if we
represent.
have in here, right? So what will be the complexity? Is that what your question is?
Yeah.
So I believe it will take the complex. I'm not. I don't want to give you a false thing. So far, we didn't see such a question. Okay.
Okay.
So when it comes, we'll try to understand that. Sachin, I don't want to give a false option for you.
Oh yeah, sure.
Okay. But as of now, if it is given, so it's taking. You understand this point, right? Whatever I have told.
Yeah, yeah. Like n square is a higher term than the like than the this decreasing term, like
Correct.
n
See,
by.
even if it is n also, it will be the complexity will be
Yeah,
n only. Right?
yeah, sure.
N by 2 also will be complex. I mean, still big O of n,
Yeah,
right? N by 5,000 is also going to be complexity of big O of n.
yes.
Mhm. So, so that's for decreasing. For equal kind of things, when it is equal, it's gonna take. Look at this log n times. But
Oh,
that base alone will change every time based on how we are dividing it.
okay.
I repeat to you. I repeat to you. So if what is that C? C is nothing but how much you are dividing here, right?
Yeah,
Okay. So if I have, but make sure that it should be equal. Okay. So n by 3, n by 3, n by 3. Okay. So all these things sum up to n, correct?
yeah,
So if I split this n by 9, n by 9, n by 9, it will come and totally sum up to n, right?
yes,
Hmm? So
yeah.
in such a scenario, the complexity is going to be log base Cn. So what is the C? C is the denominator on the division part.
Okay.
So which will become log 2n, actually log 3n in this case. If you are splitting it by 2, n by 2, n by 2, what will it take?
The
Log
base will be
base
2. Yeah,
2n. So two things are done. Simply, you have cleared two concepts. Only one, just one concept is left. If you clear that, that's all. No one is going to stop you from such a question. So I have already talked about that. So the thing is, when it is increasing, okay, you have n here, and you basically split this into n by 2, n by 2, n by 2. Navika, you also can try.
This is which one? Increasing one.
Yeah, this is increasing, right? Is it increasing or
Yeah.
decreasing?
Increasing.
Very good. Okay, so this sum up to what?
So R is 3 over here. Okay, okay.
Wait.
You're taking other sum.
Yeah, yeah. So this is what? R equals 3,
Huh.
right?
C is
And
equals to
C
2.
equals 2. So
Yeah.
complexity is, how do we write the complexity?
N raised to power,
N
order of
raised to
log
log CR,
base CR. Yeah.
okay, which is equal to N raised to
N
log
log 2, log base 2, sorry. Yeah. And then
hmm,
R is 3.
R is 3. Okay, I just want to confirm that. I'm not sure. Let's go to the bottom. Yeah, see, this is what we have done. The same thing. Navika,
Yeah, yeah.
N by
This
2.
I'm.
Sachin,
Yeah,
Sachin, okay with this?
yeah,
Uh,
correct.
Gokul, I'm just like, though I'm very clear on the. So there is this one where we have equal sum at all levels, right?
Correct.
So the complexity would for that would be order of login or n login. I don't know why in my notes I've somehow written n login. Oops, just give me a second. So sorry.
Yeah, it's N log N only. The N, okay, go ahead. So depth is log N. That's the thing.
So,
Okay, Sachin, I think
yeah,
I was, didn't complete what I was trying to say. So it was log base, yeah, N log base to N at that point, which I missed. Okay,
okay.
okay, I am not able to go back again. Fine. So we were doing something, right? I told you. So for equal terms, what was that? Big of, see, look at this. F of n into log n.
Yeah,
Okay, f of n into log n. So based on, see, this is the merge sort, correct?
hmm,
What is f of n? It is n. Okay,
yeah.
n multiplied by log n when it is equal.
So, yeah, so that's why the
Okay,
complexity is n log n.
correct. So similarly, if we come to this question, okay, we'll try to do this in a when it is same. This question is going much deeper, and I'm learning so many things from you guys. Okay, so if it was something like 2t n by 2 plus n square,
Hmm.
hmm, okay, so which means what is happening? So n is getting split into two parts, which is n by 2 and n by 2, correct?
Yeah,
N by 2, sorry, n by 4, n by 4, right? So in this case, what is going to be the complexity?
so like, so why we are having like the extra term which is n square, like as we are constructing this tree, like a recursion tree or something,
Hmm,
so why
hmm.
we are getting this n square term?
Yeah. This n square term says that how much operations you have to do in order to join them.
Oh, okay,
Uh, that's what. How much you have to do in order to join them together after the split is done.
okay.
You remember merge sort? What do? You
Yeah,
keep
yeah,
on dividing it. So that is log n times. Okay. Merge
and
sort is, yeah, I'll come
yeah,
back again. So the splitting part is log n times. And the sir used to say that addition, when you try to combine each of these
and that will be, yeah, n times,
n
like,
times.
yeah, sum of the length of the both the arrays.
Hmm. Okay. So maybe if there is a algorithm which takes, while the summing up is n square, while combining the two, right? This and this.
Yeah. Okay.
While combining, if it is going to n square, what will be the complexity of such an algorithm? That's my
So
question here.
yeah. So obviously it will be n square.
Not just n square. I want you to read this line carefully.
Okay. So all terms in the series are equal.
What does it say? The
Uh,
complexity equals complexity of f of n times L. Okay, so L is the the log n part.
okay.
Okay, so what is f of n in this case? It is big O of n square multiplied by log n. So which will be n square log n. Got the point? So
Hmm.
if it was n, so that's why you have merge sort n log n. That was a nice point raised by Navika.
Oh, okay.
Okay, got this?
Yeah.
Pooja, Navika, Anwar?
Yeah, yeah. Yeah, Gokul, just a second. I'm so sorry. Like this, if there's someone coming at home or something, I'm just getting little disturbed in between. 1 second. So in this one, in this
Mm.
question, we are having equal sum for every level in this
This
particular
question
question.
or
Huh.
the I had taken these two are different. Okay, this is the question, and we modify the question as by four
Okay.
by two.
Okay. So
In
in
such a
this one,
scenario,
hmm,
got the point?
yeah. So this sum
In
is
such a
equal for every level. So what we are actually doing is, acha, okay, n square
f of n, yeah.
into L. And
So
what is L?
L is the log part,
Okay.
log
Yeah.
base cn.
Okay. Okay.
Got it?
Yes. Understood.
So we'll move forward. Anwar also should be fine, I think, right? So here, if it is decreasing, so this is a decreasing. We only take f of n, which is this part. This
Yes.
is now making it
And
more.
if we have n instead of n square in the one that you have modified, then the answer would have been n log n, right?
Yeah, if it was n, it will be n log n, correct.
Okay.
So that is the case of, see, that what you're saying is merge sort. Look at this.
Yeah. Yeah.
That's the exact scenario. Hope it's okay, right?
Yes, it is. Okay.
We'll move forward. Okay. Okay. Um. So someone take this. Someone who is new for this can take this so that you can understand more. Sachin, do you know this? Insertion sort,
Yeah.
stable sort.
Yeah. I know that. So
Okay.
hmm, it's so like which of
Hmm?
the following statements is are correct with regard to the given insertion sort?
Correct. Hmm.
So one more like I know that it's a stable sorting, so that is
Yeah.
true.
Hmm.
And in place, it's also in place. Like we are performing the sorting within the same array, like
Correct.
original array. Yeah,
Yes.
and the complexity is yeah n square.
Let's see this. What is the best case complexity?
For
Best
best,
when the array is already sorted. Like
Hmm.
so for best case, it's order of n when it's already sorted, and when it is in the reversed or decreasing, then it is worst
oh
case, and that's n square.
Sachin got this?
yeah got it.
Okay. What about third option, Sachin?
An insertion sort after iteration of the for loop, the first m elements in the list are in sorted order. Yeah, it's true.
So one more thing which Uma wanted to tell you guys is that so they might give an insertion sort, but the order. So what should I say? The implementation they might try to change and ask, see the above insertion sort and tell something like that. Okay.
Okay.
Yeah, exactly. See, with regard to the given insertion sort. So what if they try to put it on a different list? Okay, L is here, and what if they copy another list and give return a different list? Right? That's
So
again taking more memory, right? Then it won't become an in-place sort. Got the point?
yeah.
So you need to know what is an in-place sort, what is stable sort. I don't know if they will do it, but there is chances. Just like how they did in quiz two, they might do. Navika, okay with that?
Yeah, yeah.
Great. We'll move forward. All right. So assuming okay. Who Pooja read this? Excuse me. Yeah. Pooja.
Yeah. Assuming that the median of n elements can be found in big O log n time,
Hmm.
what would be the complexity of quicksort if the median item is always selected as the pivot?
Hmm. This we saw yesterday also. Median of median. This is the exact thing which exactly I mean out of the textbooks. So okay. Uh, Who's that? Yeah, Pooja. Pooja.
Yeah, yeah.
Okay, you are here. Okay, and let's say that exactly in log n times you are able to identify the median.
Yes.
Okay, which means all the elements which is less than that can go in left of it. All the elements greater than that will go towards the right of it.
Yeah.
Correct. And yeah, they are asking you to sort the list, right? So usually, what is the case? I mean, it is not going to be big O of n. That you can tell, right? Because for I in all the elements, you need to do that, right? It's not going to be big O of n. Pooja, you okay with this?
Yeah, yeah.
The iteration itself will go this much. Okay, so and it's definitely not going to be log n. It's more than log n, right? So it's just two of these. Okay, and how do we answer this? Does anyone know? Anwar, Navika, Sachin? Hello?
Yeah, like I guess, and like I don't like this right now. I'm not getting the like idea. It's and
Yeah, Navika will be back in 2 minutes. Okay, so this is what should I say?
Yeah,
See, go ahead. Yeah, Anwar.
median of median means it will be n log n only, because finding median it is log n. Okay. Then
Correct.
after that, if you see when that recursion expands, at most it can be n.
Hmm.
That is how
and
it. N,
that will be the worst case for the like finding the medians of median. Like
no, medians of median already given. No, it is log n.
oh, okay,
So after that, so
swapping.
yeah,
See,
yeah.
you have n items to do, right?
Yeah.
So if you guys are saying like this, I can even take directly to that point, place where they do. Which week was that actually? Was it
Uh,
90? Was it 9th week or 10th week?
10th is string matching, so I guess
Probably 9th week, right?
yeah. Read path memorization matter.
Did it? Yeah, I think it should be in this week. No? My God.
I guess week like week 8.
Quick select. You're correct.
Median of median is week 8, I think.
Yeah, yeah, yeah. So he used to tell it in the summary actually. See? Selection becomes big of n times and the quick sort becomes n log n. But
Yeah.
median of the block medians, so they are finding the median of block medians helps find a good pivot in ON. So this is n times.
Excuse me.
Go ahead.
Good afternoon, Google. How are you? Yeah.
Hi,
So may
hi,
I add
Sam.
to this point actually, this question?
Yeah,
So
yeah.
what this question is saying is that, see, the worst case complexity for quicksort is n square as well, right? In the general case,
Yeah.
right? So that
Yes.
is n square. Now they are saying that if there is such an algorithm which allows us to, this is like an hypothetical scenario, right? We are
Mm-hmm.
assuming that there is such an algorithm which can give us the median in log n time, right? So if that is
Yeah.
the case, then what would be the complexity of the quicksort? Assuming that
Hmm.
we take the median always, then in that case
Okay.
it will be n log n, because see, what happens is that median also gives us median in n time, right? O of n,
Yeah.
right? So but the sorting process and all is n log n, because the quick sort itself is taking n log n time, right? So whenever we have some operation which is less than that of something else that is happening there, we'll take the higher order term, right? Whatever is the maximum. So
Hmm.
since we are finding median in log n time, but quick sort itself will take n log n time, right? In that case, so the overall complexity is n log n only.
Okay, I understand what you're saying. So,
Yeah. So in the case,
okay.
of just to add to that also, so
Yeah.
in the case of median of medians, we are finding the median in n time, right? O of n. So the
Hmm.
complexity of quicksort becomes n log n, right? And if we go less than that for finding the median, the complexity of quicksort still remains the same. It's not going to
Yeah.
decrease, because yeah, quicksort is n log n. That is what, right? That is the idea. Hope I was able to explain it properly.
Yeah, something like this, right?
Yeah.
So the overall
Because
complexity drops down.
because in the naive case, what happens is that we're getting an n square complexity on the quicksort algorithm, right? So
Correct.
we went ahead and tried to find out solutions as to how to get the median in less time, right? So
Hmm.
that we can bring down the complexity of quicksort from n square to n log n, right? So
So in
n
the
log
naive
n
case,
is, hmm,
yeah, for in, then for in, we use two iterations, right?
yeah, we have this
So,
swapping thing, and this divide and partitioning also, no? So it takes n log
huh,
n time.
huh.
So
Yeah,
yeah.
that's correct.
Yeah, so only thing is that you'll have to care about the fact that if they say something like this, like for example, consider a scenario where we have a algorithm which finds the median in n squared time. I mean, just
Okay.
saying, just saying. If they say that, then the complexity for the overall thing becomes n square, because that will be the highest thing, right? Highest order, right?
Okay.
So that is the idea. But if we go on to the other direction, we are reducing the time for finding the median, but it's not going to change the overall complexity, because n log n, the sorting itself,
Quick
swapping and
sort.
all takes
Yeah,
n
correct.
log n time. That is what. So
Hmm.
if you go into the other direction, then you need to be careful about that one. But if you are reducing, then we kind of know already that it is going to be. It
All right.
cannot be better than n log n, right? I mean, that is the best that we can achieve. In swapping and all.
Now, my
That is,
question here is,
yeah.
when can we get an algorithm, I mean, complexity like this? When?
This I think is not possible, because this see n log n is even less than n log n, and we know
Mhm.
from theory that any sorting algorithm which relies on comparisons between the elements cannot achieve better than n log n complexity, whatever it may be, right? So this is not at all possible. I mean, that is theoretically proven, right?
Okay.
Yeah, n log n you cannot get better than that. You can get I mean, bad. You can be less
Worse
better
than
than
that.
that, but yeah, you cannot go into the other direction. You cannot reduce from n log n. I mean, in the general case, that
Okay.
is the
Okay.
best case. Yeah. So only thing that you have to be careful about is they might ask the other way around also. They might say
Repeat.
that, okay, we are finding the median in n square time. Then what is the time complexity for the quicksort algorithm? In that case, we'll have to take the higher one. So in that case, the
Hmm.
overall thing becomes n squared, right? That's the thing.
Okay.
So
Was
it's a
it clear?
general thing, no? Because see, we have an algorithm which runs in n time, right? And then there
Hmm.
is something else that is happening within that algorithm, which is taking log n time. So the overall complexity remains the O of n only, no? You get the point, right?
Yeah, I get the point. Repeat. Can
Yeah.
you just repeat once again whatever you're saying? I can
Yeah,
write
so I
it
was
here.
saying, yeah, sure. So assuming, I mean, general case, not about sorting and all. In general, we have an algorithm which runs in O of n time, right? That is one thing, and within
Okay.
that O of n time that it is taking, there is something which is involving some operation which is taking log n time also, right? It is
Yeah.
O of log n plus O of n, right? O of log n plus O of n. In that case, what is the overall complexity? Overall complexity obviously is the highest order
Maximum of the
term,
one. Okay.
right?
Got
So
the
that
point.
is O
Yeah.
of
Yeah.
n only. That is the idea.
Correct.
Same thing here. We're finding the median in log n, but the quick sort
Mhm.
algorithm, all these comparisons are going to take us n log n. So overall, what we are getting is n log n only. That is what.
Hmm. Sachin,
So hope
okay
it is
with that?
yeah.
Yeah.
Sure.
Okay,
Okay.
great.
Thank you so much.
I just wanted to just little bit, add. So you told that if it was n square, then the complexity will become n square, right?
Exactly. Exactly. Because this itself, this thing that we are doing, finding the median
Yeah,
itself
yeah.
is taking n square. So you cannot
Yes, yes.
go below that.
My
That is
question
the
is
idea.
that even if they give some constant value, so let's say big of 1 or big of 15, whatever, right? If they give a
Yeah.
constant also, it still remains n log n.
N log n. N log n. Whatever
I
is the
just want to
higher.
point that out. Correct.
Exactly. Sure. Sure. All right. Yeah. Thanks.
Okay. Yeah, thanks for the reference. Any other doubts in this question?
No, I guess.
Yeah, great. We'll move further. Okay.
And just to reiterate on that aspect, see, one thing that we should keep in mind that any sorting algorithm cannot be better than n log n. So that is like a proven fact. Okay, so that works like a hint also. You cannot go,
Okay.
if they ask, even if they ask that there is comparison happening and all those things, so
Hmm?
n log n is like the best thing that we can do. I mean, we cannot go
Okay.
better than that, unless it is a specialized circumstance. In the general case, we cannot go better than that. So that is a proven thing. N log n is the best time complexity that we can achieve.
Are you saying in the context of all sorting something like
Yeah.
sorting kind of task?
Sorting, yeah, exactly.
Yes.
In the case
Any
of
sorting
sorting,
algorithm. Any
Oh,
any
sorting algorithm.
yeah, that depends on comparison. So that depends on comparing different elements. Cannot be better than in log n. That is the idea.
Hmm.
okay.
Yeah. So quick sort in that sense is the best that we can kind of achieve, right?
That's why it's called as quick sort. Fine.
Okay. Sure. Okay. Thank you.
Mhm. So moving further, this question. So who want to take this? Pooja, take this question.
Let G be a undirected connected graph. Let
Hmm.
TD be a depth first search tree of G. Let TB
Yeah.
be a breadth first search tree of G. Consider the following statement. No
Hmm.
edge of G is a cross edge with respect to TD. And second one, for every edge UV of G, if U is a depth I and V is a depth J in TB, then modulo of I minus J is equals to 1.
Hmm. So how do you solve this question, Pooja?
Yeah, thinking about it.
Anyone else want to say? Sachin, Navika, how do you guys solve this?
Like I know BFS and DFS, but
Yeah.
I'm not getting what the options are saying. Like no edge of G is a cross edge with respect to depth first tree.
Hmm.
So
Yeah.
yeah, so in like DFS,
Hmm.
we
So
may
I
have
have a question here. I have a question here. What does cross edge mean? First, tell that.
cross edge.
Does anyone know? Or if you guys
Oh,
want to add
like
different.
yeah. So
Like
inner
if
tree. Yeah,
Wait,
go ahead, Tabitha.
no,
Navika,
you
go ahead.
continue.
No, you go ahead.
So I believe if like if we have a node that belongs to so if we have node A and node B, and node A belongs to one particular parent node and node B belongs to the second parent node, like they have two different roots, uh, two different parent nodes. So node A cannot we cannot connect node A with node B.
I'm not understanding. Can you help me draw a graph
And
and show it?
in this graph, like we can't have any edge which is connecting to to other branches, like
Yeah, yeah,
two
yeah,
subtrees.
right.
Yeah. So if there is an edge which connecting two subtrees, then that will be considered as yeah cross edge, I guess.
Okay.
So
So for
for
ex-
instance, for
yeah.
example, like I'm asking, like for example, if we have Google, if you can mark like the left subtree first edge as A and the second one is B. The left one, no, yeah, this arrow as one. Just
You
come
want me
below.
to write?
name the edges. Okay.
Yeah. So yeah,
Go ahead. Go ahead.
I mean, like B and C, we cannot connect them both. Like if B has a node named X and C has Y, so X and Y cannot be connected. I believe that is cross edge. Is that so?
Like, uh,
I just
Because
want.
I had made notes and I'm able to recall that is what it is.
like we had a discussion with this on this question, like this kind of a question with Tul sir, one of his session. So there he was discussing about this cross hatch and like DFS tree or BFS tree. So
Guys, that's okay. That's okay. I explained this. This is something which I wanted to see. This is exactly what I wanted. So edge two nodes such that they do not have any ancestor or descendant relationship. Sorry, see this 5 and 6. Who is the ancestor? It's a base node, right? They don't have an in between parent. Hello.
yeah,
Okay. So 5 and 4 are completely split. They don't have a descendant or the parent as an ancestor or what the name descendant.
okay,
So given that point, okay, that means the first option is correct, right? No edge G in a cross edge. I mean, sorry, is a cross edge with respect to TD. I mean DFS. So how I'll just how I do these things is I will basically like try to draw some graph and see do a DFS or BFS. See the thing is, so if you have a point A, B, okay, and C. Okay, so if this and this, let's say like we have something like this, okay, and D, E, okay, and F, okay. Shall we try to draw a DFS for this?
yeah,
Starting from D, depth first search, D, A, go ahead. So let's say B, then C,
see,
right? E and F. So in a DFS tree, if there was a cross edge, right? So what is a cross edge meant? Means that they have I mean, what should I say?
two siblings, like, yeah,
Hmm. Okay.
having
Um.
like two siblings having one connecting age or something like.
Correct. But here, if it is having like that, then E also would have been would
Yeah,
have joined here, right? So if A was connected to E by any chance, if there was a cross edge, then the graph would change E and F. This is how it will come, and then these things will be raised. So that's the point over here. Pooja,
Yeah.
that's the point. Did you understand something? There is something called as forward edge and backward edge also in case of BFS and DFS. I'm not
yeah,
sure.
yeah.
I'm not recalling those stuff. Okay. But Pooja, you understood this cross edge, right?
Yeah.
Great. Okay. Go ahead now. The second option,
For
please.
every edge u v of G, if u is a depth I and v is a depth j in TB, then modulo of I minus j is equals to 1.
Okay. So that was for a depth first search, and this is for breadth first search.
Yeah,
Okay.
so I guess it should be like difference of the labels, like absolute difference of the labels should be less than or equals to 1 for BFS tree.
Hmm.
So yeah, so like it's saying exactly 1, so that is not true. It can be 0.
That's the point.
Yeah,
So Pooja, how much did you understand this? E F. Okay. I'll just try to draw some little bit. So F is already there, right? Then this has to be G, H, and I.
Okay, so these are drawn. I'll also try to join these. This is BFS. So I can try to possibly add these and then link this with this, then link this with this. Okay. So Pooja, can you help me draw a DFS for this?
FS or BFS?
Sorry, it's a BFS. Huh? Okay, BFS for this. BFS starting at A.
Yeah.
Hmm? A,
A,
then all the things
B,
connected directly with A, which is B,
B, C,
C.
D,
Very good. That's all I think, right? A is connected with three other edges, three other nodes. Go ahead.
B to D,
Then we'll go for B. B to D is already done, visited.
B to F,
Very good. B to F. And C is already visited. You
done,
can't go anymore else, right?
and C to, what is this? E,
Yeah. C, F. Okay. F is okay. First E, right? According to the ascending order. I mean alphabetical order.
and then G,
Why not? Okay. F is already visited, huh? Okay, fine. E, then G,
then E to H.
C,
No,
and
no,
also you're looking
C
for
to,
C,
yeah, yeah,
right?
E to I.
Okay. See, the best thing to do this is basically you just see how many edges C is surrounded with. 1, 2,
Yeah.
3, 4, 5, 6. Okay. Just check if all the vertices are covered. So C to A is already A is covered, B is covered, D is covered, F is covered, E is also covered, G is also covered, right? So one more edge which is I. Okay,
C to
I
I,
and uh, G to I, right? So
C to I,
yeah, C to I. That's what I'm trying. Okay,
then
so I is also covered now. So from E to H.
H.
Okay, so now you have drawn a graph. Sorry, that's a graph, and this is a tree, right? And this is a what tree? BFS tree. Nice. So for every edge U comma V in G, so you have so many edges. If U is at depth I, so shall we take one edge? Take one edge. Can you tell me one edge, Puja?
B to D,
BD. Okay. So B to D. Fine. If U is at depth I, so what is the depth of B? The tree. So let's say that this is zeroth level, and this is first level, this is second level, and this is third level. Okay.
yeah,
Hmm? So what is the depth of B?
depth of B1,
1. Okay. So I equal to 1. Go ahead. J equal to what is the depth of D?
B, 1,
Depth of D is also what? 1. Hmm. Depth of J is also 1. So they are saying that I minus J is always equal to 1.
no, it's false, 0,
It is false.
become 0.
So it can be 0, but is it possible to say? Is it possible to get a -1?
-1, but here modulo taken.
Oh, it's modulo given, huh? Okay, yeah, that means plus or -1 they are saying here, right? So that means it can be plus. So that's okay. I think it's okay. No, I don't need to talk about that. But you guys understand, right? So the for a BFS, the what is it? Depth is going to be +1, -1, and 0, right? If you have depth of this thing, then there is a direct edge. That's the point. Guys, is that okay?
Yeah, it's clear.
Hmm. So that's how you answer that. We just need to prove that point wrong, right? We'll go to the next question. Navika, okay with that? Anwar, Sachin should be okay with
Yeah,
that, I think.
yeah.
Okay, Navika has left. Fine. We'll go to the next question. Anwar, you want to take this question? Now they're talking about the cross edge. Nice that we have questions on this. Anwar is not responding. Anwar, if you are here, you can take this. Okay, Sachin, can you take this?
Yeah, sure.
Hmm?
So consider the following directed graph.
Hmm.
Then DFS on this graph, a vertex 0, which of the following is a cross edge?
Okay, let's first draw the DFS for this. Okay,
Yeah,
start from 0. In case of
so
multiple neighbors, the algorithm picks the smallest labeled value. Okay, same
yeah, so
0.
from 0 to 1, and then
Hmm.
1 to 4.
DFS. Okay.
Yeah, 1 to
Hmm.
4,
Okay.
and then 2.
Hey,
Yeah,
4 to 2.
yeah. Then we will start backtracking, and then
Right.
go back to 4. Yeah, 4. Then go back to 1. Go back
Hmm.
to 0.
Okay.
And from 0 we will move again, like move 3, like 2 is already visited.
Okay.
So 3 and then 5.
Hmm. That's
Yeah,
all.
then we stop. Yeah.
Okay. So what is the question asking?
So like it's asked. Oh, yeah.
Sorry. Yeah.
Hmm.
Hmm.
Like, can you?
Yeah. So read it. Which of the following is a cross edge? They're asking which among the following is a cross
Yeah,
edge.
yeah. So we have to check for the ages, which is a cross age.
Mm-hmm.
Cross age. Yeah. So it's like 0 1 is not a cross age since it's present in the tree,
Correct.
and 0 3, 0 3 is, yeah, it's also present there in the tree.
Yeah.
And for 5 2, like 5
Hmm.
and 2. So 5 2 is a cross edge. Like yeah. So it's as you can see in the DFS tree, if we draw the edge 5 to 2, it will be connecting like two sub trees, like different
Hmm.
branches
Hmm.
of the
Hmm.
tree. So
Okay.
obviously it will be a cross edge. And for the
Okay.
next, for the last option, like 0 2, yeah, 0 2
0 to
is,
2.
yeah, 0 2,
That's a forward edge.
yeah, forward edge.
Hmm.
Hmm. So it's a forward edge.
Okay.
Yeah.
Yeah. So if we had something like if we had something like this to this, right? So which is from 2 to 0 or 2 to 1, let's say. So this is called as a backward edge. So you'll have an edge which you won't see in this. Got the point?
Yeah.
Now you remember this? 0 to 2 is a forward edge, and here to here is a backward edge. And if it's connect between two branches, then it will be a what is it? Cross edge.
Yeah.
Pooja, okay?
Yeah, please
Repeat. Are you asking me
see
to repeat?
question once again.
Yeah. Okay. So what is the cross edge? Okay. Simple. You draw the BFS.
Yeah,
Okay. After drawing the BFS,
it is
so
DFS. DFS.
sorry, DFS. I'm sorry. Why am I getting wrong with the terms? Sorry for that. Yeah, DFS or BFS. That's fine. Okay, in this case, it's DFS. Okay, after drawing the graph, you can see that there are two different, branches, right?
Yeah, yeah.
Okay, the edge which is not in the what in the graph, and if you draw that edge, it will connect the two branches together. See, you have an edge 5 comma 2 in the original tree, right?
Yeah.
So if you draw 5 comma 0, I mean 5 comma 2, then it is a cross because 5 and 2 are they are in a different branch altogether. Similarly, can someone tell another cross edge? Sachin, can you tell me what is another? Can you tell me one more cross edge?
Hmm. Hmm. Like 4 to 2.
Correct. So if you draw that 4 to 2 in this tree, then it will connect
Three
the two
now.
branches.
4 to 3.
Sorry, 4 to 2. Oh, sorry, I think yeah.
It's already
Oh,
connected.
sorry,
Four
sorry.
to two.
Yeah. I mean, I thought like that was 3. Bad handwriting. 1, 2,
So,
3, 4, 5,
so
6, 7. 1, So 5 comma 2 is missing. What is the other edge that is missing over here? Is it 0
2.
to 2? Yeah,
0 to
0 to
2
2, which is a forward edge,
and 2 to
right?
1 backward edge.
That's something which I drew, right? 2 comma 1.
So I guess
Yeah.
I guess there will be no more such cross edges. Like uh, as we count the number of edges in the tree and in the original graph. So
Hmm?
original
No,
graph
if
having.
we joined 4 to 5, then it will
Oh,
be
okay. Yeah,
cross
Correct.
edge.
That's what I was thinking. That's nice.
Yeah.
Okay. So if we draw from 5 to 1 also, it's a backward edge, right? Sorry,
Yeah,
sorry,
yeah.
it's a cross edge. I mean, back
It
cross
is.
cross.
It is.
Hmm. But if you draw 1 to 5, okay, if you draw 1 to 5, will it change?
Forward
That's
edge.
also,
No, no, no.
yeah, that's
Cross
a
edge.
forward edge. Forward
Forward.
edge, but it's a cross edge, right? 1 to 5,
Yeah.
is it?
Cross edge.
But it still won't affect the graph, right? As we have given the condition that ascending order, smallest labeled value. All right. So we'll move forward. Okay, a little bit, guys. Pooja?
Yeah, clear.
Okay. Right. Afnan, are you still here?
Yeah, yeah.
Yeah, please take us.
Okay. Extra. Huh?
Hmm?
All right.
I'm
So
taking
we'll
the.
have to run the extra on this one and find out which nodes are vertices in what order. Which
Hmm.
nodes are visited in the correct order, right?
Okay, fine.
Sure. Sure. So I believe we are starting from A, no?
Yeah, seems like every option has A at the start, which means it's a A.
All right. Sure. Sure. Oh, yeah. It is written also, no?
It's
Run with
also written,
vertex
yeah,
A as the source
A
vertex.
as
Okay.
source node.
Sure. Sure. So yeah. Okay. Just as you do. So we'll start with A and then we'll do no at 3 at time 3 we'll be at B. So maybe you can kind of cross that off also so that we'll know that we have visited that edge. Yeah.
What do you want me to do? The cross out the edge, huh?
Yeah. Because you'll have to sum it, no? Also
Sure.
to yeah. Yeah.
Hmm.
And then since we are at B,
Hmm.
so we can either go from A to F, which is 6. It's taking us
Hmm.
6, and we are at 3 only, already. And from
Hmm.
B to F, it is going to take 2. So 3 plus 2 is 5, whereas A to F is 6. So we'll first visit F, I think.
Why
Is
not
that
from
after
B?
B? Yeah, okay, there is one also, no? Yeah, yeah, in that case, D first. Whatever is the smallest from
Hmm.
wherever we have reached till now. So from there,
Correct.
we'll see.
Hmm.
Okay. So we have visited B and D. We are at D now, and E also. I think the very next one is going to be F only. No,
Hmm?
yeah, yeah, because once we visit D at that time, F would have been visited also, right?
F?
So
No. No, no, no. Next to 1 minute only it will visit F. Basically at the fifth.
okay, is it? Oh,
Yeah,
okay.
yeah.
So you have removed that two, and in place of that, you have written in one, right? B to F. Yeah,
1 by 2. Basically, I
one.
have to.
Okay, okay,
You,
sure, sure,
you have covered
understood.
1 minute of the two.
Okay, sure, sure.
So
So
now
yeah,
so
F
5
is
by 6.
visited.
So which means this is also visited. You don't need to worry about this anymore.
Okay, okay. So
Right?
it means that if we visited actually from A and not from B, right?
Repeat.
So I'm
Ah,
asking that
F
if
we
we have
visited from B. We visited from B only.
okay, we visited from B.
Hmm.
Okay, so all right, okay, okay. So we visited from B only. No, but you just said that it will be like after 1 second only,
Yeah, bro. You still have one out of 6 minutes left, right? But if you come through this way, you can
right?
reach it in 5 minutes.
Okay, from B, huh?
Yeah, from B, correct. Because you have a 3 here.
Right, right.
3, 2,
That's what. That's what.
3 plus 2, 5
Initially,
and
we had this three, so that is taking time.
yeah,
Yeah,
yeah.
okay, sure, sure. So
Hmm.
D and then F we will visit. After that,
Hmm.
so this 2 that is there from D to C, I think that will be visited next after that. No, because we
Hey,
are already at D and then it is 2. So I think C will be visited after that.
so we'll put the the what timing accordingly, man. Seriously, this is confusing, right?
Yeah,
That's
yeah.
what it will be.
Because
Initially,
you have to
everything will be
actually, yeah, because you have to keep updating, no, each iteration.
yeah, yeah. We'll go according to the logic that professor has taught us.
Okay, sure, sure.
Mm.
All right,
So when you come here,
Hmm.
hmm,
Right.
you can see that it takes 6 minutes. You can see that it takes 3 minutes.
Yeah, yeah, that is cool. Yeah, okay.
Hmm?
Yeah,
So
among
so
the
this is
two
zero. Hmm.
that we can visit,
Among the
we'll
two,
visit
which is the smallest?
which is smallest. So B.
Yeah, 3. So you go to B, and you 3 is visited. So I'm gonna
Yeah,
cross the visited vertices.
sure, sure. Yeah, that's what.
Okay. Okay, fine. So now that you are here,
Now,
from here,
what are
what are
uh,
all visible?
what are all adjacent? Maybe you can kind of sum it and add it. So, like for example, in the case
4.
of C from B, we will get 7, 7, no, because 3 plus 4 is going to be 7 only. For
C,
C,
yeah, this will be 7. Correct. Hmm.
7. That's what. And then from among these, we will choose the minimum. That's what. That's the
Yeah, this is
mechanical way to go
D
about
plus
it.
2. Now you will update this as 5
Yes, it's going to be 5.
because
Yeah,
D plus 2.
from B. Yeah, correct.
Okay, now that this is visited, so what's the next minimum? So 4, 7, and 5 of the
4.
3. What's the next minimum? 4.
D.
So B to D, right?
Correct.
So
Yeah.
now that you have visited this, now we'll try to update the value. So 4 plus 2,
2 is
which
6.
is if it is minimum, you update it. 6.
Yes, of course.
Okay, you have
6.
one more edge here. So what is this gonna be?
7.
7.
7. 7. Yeah.
Yeah, 7. Right? So
And
6,
from F,
7.
I think
You just have
F
only
we have
2 new
visited.
nodes.
Sorry, F we have visited, no? So from F to E also we'll kind of.
F we still did not visit, no?
Okay, not yet. Okay, you have not crossed that one.
Okay.
No?
I
Okay,
have not
sure.
crossed. So you're
Sure.
at 4th minute. Right.
Okay.
So now you
Let
have 5, 6, and 7. Simple. Now
oh,
you can
oh, 5.
now you're
Yeah.
gonna visit this
Yeah, visit for F. Yeah. F.
5. So if F is visited, okay, you're visiting F at 5. So 5 plus 4 is 9. So you don't
9.
need to do that. 9 is
Because it
bigger
is
than
already minimum. Yeah, sure, sure, sure.
okay. So that's also now everything all the vertices of F has been exhausted. Now we'll see the minimum. Now 5 is not equal. So minimum of these two, which is
So 4, 6, and
C.
7. So C.
Not 4,
6.
6, and 7. 4 you don't
4
have.
is
Just 6 and
4.
7.
Yeah. 6 and 7. C.
Hmm. So 5 was F, I think, right? So F,
Yeah.
and then this is C, and then finally
E.
E.
E. So A, B, D, F. F, C, E, I think.
ABD, FCE. ABD, FCE. Yeah.
Is that
So
correct?
correct.
Okay. Sure, sure. All right. So it's
Hmm.
better to always, mark this down and see what are
Hmm.
all the,
So put.
remaining time till now. So
Hmm.
it is better to do that way because we tend to lose track of, where we are.
Correct. Exactly.
Yeah.
Hmm. And
Sure.
this just needs one. I mean, 1 or 2 times if you guys practice this, automatically it will come. I
Yeah.
mean, this is the how algorithm works, right? You don't put infinity, then take the minimum. Exactly, we
Yes.
did according to the
Exactly.
algorithm.
Exactly. According to the, code also.
Yeah, yeah. Okay. Sachin, Pooja,
Yeah, it's clear to me.
great. Sachin also. Sachin, Sachin, right? Have you guys heard this Sachin anthem song? Okay. So Pooja, Anwar, are you here? Okay. Pooja, can you take this? I don't know. Anwar. Hmm.
Let G is equals to V comma E is an undirect graph having distinct
Okay.
positive edge widths. Let
Hmm.
V be partitioned into two non-empty sets X and Y. Let E is equals to S comma T be the minimum cost edge
Hmm.
with S belonging to X and T belonging to Y. Which one of the following is true?
I wasn't able to follow this, but if you follow, please explain. Hmm? If you have followed it, please explain. Did you follow the question, Pooja?
No.
Then take it slow, na. I mean, I'm asking you to read it for you to understand it.
Okay.
Okay. So graph G has vertex and edges. Okay. So V for vertices and E for edges, all the edges that you have. So undirected graph, distinct positive edges. So all the edges are positive and they are distinct. Okay. So
Yeah.
so far, I think this
They
is clear.
into two non-empty sets X and Y,
Okay. Those
but
vertices. So vertices are being split into two.
X and Y.
Okay. X and Y. Great. So E equal to S comma T. B minimum cost edge. So that's the lowest edge among the all.
Yeah.
Okay. So
Mhm.
with S belonging to S. So what does it mean? With S, S is the what is it? Oh, S is the source vertex,
S
huh?
belonging to X and T belonging to Y.
Okay, S is the source vertex, and T is the this is the shortest edge. Let's say it is the one. Okay, so this is a different set, and this is a different. This is belonging to S is belonging to X,
Yeah, yeah,
and
yeah.
T is belonging to Y. Okay, which one of the
Yeah.
following is true? Okay, so there are two things, two properties of MCST here. Pooja, hello.
Hello.
See, one
Yeah.
property is that, yeah, you are audible. One property is that if you have all the edges which are unique, then there will be only one MCST.
Yeah.
Are you aware of that?
Yeah. Yeah.
Hmm. So, as they are told, this is the minimum edge. Minimum edge will always be there in the MCST, right? Always.
Yeah.
So, so that's the answer. So, what about the other options? So they are having multiple, must exclude. Okay, that's okay, right? That's very easy. Very simple. Yeah, Nafna, please go ahead.
Yeah, one question, Gokul here. So this inclusion part is not always valid for the case of cycles, no? As we were discussing the other way also, other day also.
Yeah, but okay, must include the edge E. So let's say that this is what we have. Okay, Afnan?
Yeah, yeah.
Hmm? So 2, 1, 3, 4, 5. I think this is the graph that you're talking about.
Yeah. Okay.
I mean, wherein you form a cycle, right?
Yes. Yes. Indeed.
Indeed. Hmm. So what is the MCSC of this going to be?
AB,
Uh, okay, yeah, AB,
AC,
AC,
and BC will not do because it will form a cycle, right?
hmm,
So CD.
yeah,
That's all.
CD, right? Okay. So what do you say? So it is not necessarily. I mean, one is it required to always be in the MCST? Are you talking about
Yeah,
that?
that was the question because there's this assumption in this answer also that we're going to always
Hmm.
include that one. So that was the question.
Okay. Let me put something like this: 1, 2, 3, 4, and 5. See, if we
Yeah.
have, I mean, I'm just trying to see. Okay. So what could be the MCST of this?
So you have not written down the names of the vertices, huh? ABC.
Okay, you want to? Okay. I thought like you can just tell the vertices. You know,
Oh,
C
okay,
and
fine. Yeah. So that we can
ABCD.
do
Oh,
that.
A, B, C, D. Cycle.
Sure. So I mean, according to Kruskal also, so AC. We'll first pick AC. So
Exactly.
anyway, we are going to start. So we'll okay. That's the idea.
AC. That's the idea. That's how I took the
Okay,
answer.
okay.
Got it?
Whether it be part of a cycle or not, if it is given, if it is the absolute minimum age, that is going to be always included because
Bro,
we're going to start.
even if it is a part of here also it's a part of cycle, right?
Yeah, yeah. That is what
Okay.
I'm saying. But given the condition that it should be the minimum among all,
Hmm. Correct.
yeah, because had it been the second smallest or something like that, then it is not necessarily true always, right?
Yeah, that's correct. That's correct.
That's the idea. Okay, so there is this thing also that it has to be I mean, absolute minimum, first thing. And the
Hmm.
second thing is that even though it is part of cycle, it will always be, I mean, necessarily be included in the MCST.
That's the Pushkal
Whether,
algorithm case now.
Yeah, yeah.
Start with the
Understood.
minimum postage.
Start with the minimum mustard. Yeah. So whether it be part of cycle or not, we are not taking into account that one. Okay.
Mm.
Yeah. And the other
Yeah.
thing is, of course, distinct positive edge weights. So that says that there'll
Mm.
be only one MCST. So that is this.
Right.
Okay.
Mm.
Sure. Thank you so much. Yeah. All right.
Great. Nice. Right. So upfront, you can take this. This is an easy question. How many? Once again, let me just see how many questions we have. 323, 425, 26, 27, 28. We go to the next. Okay.
Lots of questions, huh?
Yeah, 1 hour. I think the exam is for 1 hour, right? Approximately.
No, 1 hour is the usual thing, right? So for every paper there is 1 hour. I think this is 1.5 on.
Oh, 1.5. Ah, 1.5. Correct. So
Yeah.
it's for 100.
Gokul, can you send this link to the previous year question papers on? Okay, you're sending it. Okay.
I'm just sending it over here. Take it.
All right.
Yeah. So if you want the whole thing, it's here. Okay. I mean, it's also here. So you're into direct diploma, right?
Yeah.
So I have sent you the site. Go. Let's go ahead. Okay. So do you guys
So we are
have time to,
sorry. So we are doing the immediate previous term, no? May term.
Yeah, this is the no, not the May. Yeah, I mean, exam was on May term, but exam was
Yeah.
on August.
Okay.
Ah,
All right. Yeah, yeah. I mean, I'm talking about the term itself. So it is May term
yeah,
only,
yeah.
no? Yeah, yeah.
Hmm.
Okay. Sure.
Go ahead, upfront.
Yeah. So what is the question? We'll first read that one. So the maximum and the minimum number of nodes possible in a binary search tree. So this is a binary search tree, which is sort of easy to understand also. Now
Hmm.
of height, what is the height given? 6, huh?
Yeah,
6 are all right. So the maximum possible number of nodes will be 2 to the power of whatever height there is minus 1. So that is 2 to the 6th power minus 1, which gives us 63. So we are good to go.
yeah. 2 power 6
And
whole minus one. Hmm.
yeah, because 2 power 6 I think is 64. And subtract 1 from that, we'll get 63. No, yeah,
Correct.
that's all. Okay, and the minimum number of nodes. Okay, so given that it is a binary tree, what will be the minimum number of nodes? There will be. Okay, so that I'm not very sure. In which
Just
case it will be happening.
bro, simple, bro. What is a binary search tree?
Okay, so height is 6, huh? Alright, alright. So of course, yeah, yeah. If the height is 6, then at least one node will be there. That is kind of the minimum that we can get to. And of course that gives us that there will be 6 nodes. So yeah,
Yeah.
63 and 6. Yeah, yeah. That is, and the other case basically H only, no? That's
Haha.
linked list, huh?
Repeat. Sorry.
It's like a linked list.
It's just a straight line, nothing else. When
Straight
it-
line,
when the
yeah.
when the, when the order the array is in ascending order or descending
Correct.
order,
Correct.
it will be a straight line.
Uh, okay.
Navika,
And
were you able
uh,
to?
Yes, yeah, I understood this. What if there would have been another case wherein it would have been considered that the height of the empty tree is 1? Because in Atul sir's class yesterday, when I attended day before yesterday, so it said that there could be two cases and it would be
Hmm.
given. So if had it been 1,
Had
then
it been
it would
one,
have, yeah, then it would have been 2 raised to power 6 plus 1.
no, 6 minus 1,
6
minus 1,
minus 1. And this minus 1 would still remain? Like,
minus 1. Yeah, that's correct. Okay, basically you're saying that, see, you have a tree, okay? Let's say this is the first level, second level, third level, fourth level, fifth level, and sixth level. Okay, let's say that this is the 0th level. Okay, they are
yes.
saying that if you start from 0, the height is going to be like this, right? You'll have something like, something like this. So if you start from 1, okay, then how much you will have? You'll have 1 less than that, right, Navika?
Yes. Okay.
That's all. You'll have 1 less than whatever was there. So n minus 1.
All
What's
right.
the point?
Yes, yes.
The same goes for the minimum also. Okay. Any
Minimum
more
still
questions?
remains the same, no? Minimum still remains the same.
Comes to 5. Minimum comes back to 5.
Okay, okay, okay.
What are you asking? They're asking number of nodes,
In
right?
this case, yeah, in this case, if the base would have been like the
Hey,
empty
wait a
tree
second.
would have been 1, then how
Hmm.
much would have been the minimum number of nodes? 6 or 5? 5, right?
Hmm.
I think minimum
After
would be the same. It would be 6 only. Yeah.
Yeah, Google. Just to add to this, see, they
hmm.
are saying that the height of the empty tree is considered 0. It's not like one node, no. So even if it is one
Ah.
node, we'll consider that one only. So that is not, that is the normal case, no.
Hmm. There is,
It-
yeah, if there
The
is a
other
single
case
node,
I think that we are talking about, I think the other case that we are talking about is when we consider a tree of one node only having a height 0. So that is a different thing. But here they are saying that empty tree is considered a height 0. So which means that if I have one node only, which is the root node only, then I'll consider the height to be one only. So that is the normal case.
yeah, empty tree cannot have a height of 1.
Yeah, that's the idea.
My God. Thanks, friend.
Yeah. Okay. So in this case,
Navika,
I
you
think,
understand?
in this case at least, I think we don't need to do that -1, no, to the
Ah,
edge part.
exactly. Yeah, yeah.
Yeah. Okay. Sure. Sure. It's clear. Thank you.
Navika,
Yeah, okay,
understood.
understood. Yeah.
Which means that it still remains the same. So
Yes.
empty tree is 0, or if they say that the first node is going to be of height 1,
Yes.
it will
Then
still
it would
remain the
have been, no, no, if the first node is of height 1,
same. Hmm? Tell
if the
me.
first node is of height 1, then we would have done 2 raised to power n minus 1 minus 1,
No,
right?
2 raised to power n minus 1 only. That's what. See, empty tree, if there is nothing, it is of height 0.
Yes, right.
Okay. If you have, whenever you put a single node over in the tree, okay, then this become a height 1.
Okay. I'm not too clear what Sir mentioned in his lecture. He did surely mention about this, and that's the reason I've noted down also. And maybe
Okay.
rewatch that, what he said.
Hmm.
He said because we can, in some cases, we treat the first level as height 0, and at times we treat it as height
Hmm.
1. So that
Hmm.
particular case
So,
would have been mentioned in the question itself. That is what he
exactly.
said.
So, hmm.
It is that question came about the number of leaf nodes and number of nodes with the children. Actually, the one question was there: how many nodes was there without with the node having two children? So number of nodes with the two children will be equal to number of leaf minus one. That
That's
was
correct.
the same thing in the binary tree. Also the same thing. In that
Yes.
context only, it was discussed at that time. Because root node will have only one. Root node will not have will have only children. It will not have any other thing above it. So it was
Hmm.
considered as a one, something like that.
Yeah, that's correct, Balaji. Navika, he's saying that was on a different question, it seems.
Okay, I'll rewatch it maybe for my
Yeah,
clarity
yeah,
then. Yeah.
sure. We'll move forward from here. Hmm. So I think like, shall we finish it off, please? I mean, today in this session itself, if someone wants to take, I mean, so anyhow we are recording this, so you don't need to worry. We have more people coming in and more people leaving out. So let's keep. I mean, we are in a good speed also. Shall we finish it off? This question paper completely, guys? What do you suggest? Afnan, will you be there? Till we
So
finish this
yeah,
question
do
paper?
we have a session at 7 today also?
I thought like if we finish this, we won't have it.
Okay, okay, sure. Yeah, yeah, that is okay.
Do you
Okay.
guys? I think you guys are having a recent session at 8, I think, right? I remember.
Yeah, yeah. Today there is one. The last, I think the last one for BDS is today only, which is 8 to 10.
Huh.
Yeah.
Uh-huh.
So that
So,
anyway will be joining. So I might have to go in between, but I'll try to be here. Okay.
yeah, we finish this up fast.
Sure. Okay.
Balaji, okay? Navika? Pooja?
I'll try to be here, but I
We
have got
will
some
I'll
work
try.
also. But I'll come. In between,
Hmm.
I'll go and join. I'll be join intermittently. I'll be there and I'll go.
Okay.
But I'll
Navika,
be.
what? Navika and Pooja, what's your thought?
Yeah, like the same case with me as well. I really don't know. I have few meetings lined up after this, so
So if you
I'll
guys want,
maybe
we can
attend
wind
that.
up and then join again later.
Yes, yes, that's what I'll do. other anyway, any which ways it's being recorded, so I'll watch it.
But if everyone leaves, no one is there to answer now.
Yeah.
It's not about watching. It's about asking your doubt and then here and there, here itself. That's the
So
point.
how many questions are there left to do, by the way?
So 24. Okay, the starting is 24.
All right.
More
Okay.
complex are coming.
Questions are coming up. Huh? Okay.
Yeah, yeah.
342. Huh? Okay. All right.
19 questions are left.
19 questions.
Hmm.
Yeah, it's doable. Anyway, if we do it now,
We'll leave.
then we'll not
What
have.
we shall do is we will we'll try to do as much as possible. 19 questions
Yeah,
left.
yeah. If anything, is left out, maybe you can see if there is something that can be done at 7 also, if possible.
Yeah,
Uh,
sure.
yeah.
Okay, not this much. Yeah, 24. Here we are. Okay. What is this question saying? Pooja, can you take this?
Yeah.
Hmm?
Consider a complete binary tree with n nodes
Hmm.
where the left and right subtrees of the root are maximum heap.
Hmm.
The upper bound to convert the tree to a maximum heap by an efficient algorithm is
Hmm.
This is basically heapify, right?
So they're saying that, yeah.
So that takes order of log n.
Hmm. So I'm just trying to understand here. What do they mean by this? So we have a max heap here, also max heap here, and we have something. So which means this is going to be an in-between value, right?
Check only the topmost thing. Topmost two and
Yeah. So this is going to be between these two, right?
that means it will be a binary tree type.
Yeah. See, it is. They are saying that we have a complete binary tree with n nodes. On the left-hand side, it is a max heap. Right-hand side also, it's a max heap. Okay. Fine. We'll do something. Wait. I'll just show you an example. Okay. One, and the maximum value is going to be here. That means we'll not have a. Okay.
So, excuse me, Google. Sorry to interrupt, but can we clear that up first? What is a complete binary tree? Because there are several variations, no? Complete and
Okay. Okay.
not and like that. So, before moving ahead, I think it will be better if we just kind of revise that also, because then I think that is also playing some role here, right? It's a
So
complete.
what is it? Okay. This is a binary tree, not a binary search tree. Damn.
Okay, okay. So there is no order, huh?
Yeah, there is no order here. It's just a binary tree which is complete.
Yeah. So
No,
if you could just once again recap that by complete thing.
there are two different things, right? One is complete and one more is full.
Full, yeah, full and complete. So this is slightly confusing at times. So it is better to
We'll see
always.
this is complete. We'll see. Example. Now,
Okay.
see
So full tree means that
it.
what?
Okay.
What does it
So
mean?
full tree means that single child or no child.
All right. And in the case of complete, what it is?
Complete tree
Okay.
means every layer is complete. Only the last layer is not complete.
Okay. So that having no no node is not possible in the case of complete above the last level. Is that what you're
Uh,
saying?
Yeah, correct. You're right. So the previous layer should be completely filled. Only the last layer you can have an empty space.
So can I say like that the complete tree is a special case of full tree? I mean, because a complete is anyway full,
Hmm.
right? A
Yeah.
full tree might not be necessarily complete, but the other way,
Mm.
the complete tree must be a full tree, no?
Seems so.
That is
It
what.
shall
So
be.
it will be like easier to remember like that. That's why I was trying to find out the relation.
Mm-hmm.
Yeah, they are
Look at
saying
this.
it's saying good example. So they are saying that complete binary, all the levels are completely filled except possibly the last level. Okay, sure.
Mm-hmm.
And full binary will have to have I mean that exception for the last level is not there in the case of full. No. Okay.
Mm-hmm.
Okay.
Yeah. So, and what if everything is completely filled? So that's what I
And
think.
what is the okay,
Perfect tree.
perfect. Hmm.
Nice
Complete, perfect, and full.
and full.
So it is like we have a complete tree, then a
Mm.
specialization of that is a full tree, and then we have a perfect like that.
Mm-hmm.
Kind of.
Correct.
Yeah.
Kind of.
Okay.
Go ahead.
Sure. Makes sense. Yeah. So this is a complete one, which means that the last level might not be necessarily, filled completely.
Correct. Only the last level, right?
Only the last level. Apart from the last level, everything must be filled in.
Mm. So let's say like this.
Yeah, that works. Mhm.
I can have something like this also.
Yeah, probably you can have. So
This is
only
still a
that,
tree, right?
uh, only the left part of that root node on that branch only you're not completing, because this
Yeah.
is intermediate node. We do not have the right thing, only the left.
I'm not understanding. Repeat.
So from the root node we have the left, no root, we
Yeah.
have left. So that left, we do not have a right on that.
Correct.
That is why it is not a full thing, right? It's a complete one
Yes. Yeah.
because we are missing out on that. Okay. Yeah.
It is a full only, right? Complete tree is also full tree, na? Bro.
Complete is full or full is complete.
Full. And then
Okay.
inside you have complete, right? Inside you have perfect. Yes or
All
no?
right, Google, but I am not very sure. I
Hey,
think it is the other way around. Complete, then full,
what
and then.
what what, what is a full binary tree? Every node has a zero or two children. Okay, okay. That means this is
Yeah, that
wrong.
is what. That is what. So that is what I'm saying. It's complete but not full. No, it is the other way around. So it is like complete. Inside of that, you have full. The terminology used here is slightly confusing.
Look at that. That means okay.
Yeah,
Nice man. We came up with a different one.
that's what.
Okay, nice.
Yeah, this is the complete one, not a full.
Yeah, complete, not full.
Full means full, right? So you can take it literally also, right? That's what.
Hmm. Okay.
It's complete.
Complete means
Last level
what?
exception only.
Hmm.
So exception for the last level, everything else. Apart from that, it's full. And we have the perfect one lastly. Perfect is perfect. So
Perfect is perfect. That's fine. Okay. Now let's read the question.
sure. So this example, I mean the thing that you have drawn, just to reiterate, this is a complete one.
Huh.
Yeah, sure. Okay, then in that case we can move ahead because the example suits this question. Okay, sure.
Mm-hmm.
So they
You
are
only tell,
saying,
no? Hmm.
okay. So no, I am not very sure of the exact answer, but yeah, I'll go about it. So
Hmm.
the left, they are saying the left subtree, which means from the root node to the left, you'll have everything which is a max chip. So you can kind of draw a circle here, or like, no, like that. Yeah. Please go ahead.
No, full complete tree means full is basically with respect to the nodes. Except for the leaf node, every node will have two children.
Correct.
So that single node can. So,
Correct.
but
Hmm.
at any level, the leaf can be there. Something like that is there. Complete means it
Hmm.
should be complete filled level by level. So emptiness will be at the last bottommost only. Then it is
Correct.
called complete.
Yes.
Complete means at every level it is filled up. Like a BFS, every level it should be filled up. First
Mm-hmm.
level filled up, second level filled up, third level filled up, and finally vacancy will be available only at the last level. That
Hmm.
is called complete tree. That
Okay.
last also, the completeness will be coming from left to right. So
Mm-hmm.
if it is coming from the vacancy, should not be on the right at the case of left and all that. So
Okay.
that vacancy should come from left to right. So that is called complete. Complete means with respect to the level,
Okay.
and full means it is respect to the particular node. Like it is a full means node centric. Complete means it is a level centric.
Okay. Good.
Sure. So in that case, can I say that in a full binary tree, the number of nodes will exactly be 2 to the power n minus 1? Is that right? Because it is full, so obviously every node that is there will have.
Full doesn't mean every level is completely filled up. What you
Okay,
are
it can be
telling is
zero as
completely
well.
filled up only it will come like that. That's why
Okay,
max heap and all that will be it is
understood. Because the provision of zero is also there, no? Yeah,
when
zero.
every level is complete level by level only whatever your the formula holds good. Otherwise it all depends upon the particular structure only. It is a
Okay,
full
understood.
means it is only that leaf full means only leaf node will not have children. Other than that, all the other nodes will have two children. That is called
Okay,
the
full.
This is full.
This
Balaji?
is
which one? Green.
Yeah, green one.
Green is full
Correct.
yeah,
Afnan, got
because
it?
the leaf node
yeah,
other
got
than
it.
the leaf all are having this thing, but it
Two.
is not a complete because complete means level by at level one you see.
Hmm.
Other than the root, that it doesn't is not complete. So
Correct.
every level is not complete. So
Hmm.
that
Level is yeah, understood. Thank you.
respect to the node. I think any binary will be like that. We can term it as every node other than the leaf should have two children. That is the key.
Great.
Sure.
This is simple. Okay. So we have they are saying that this is a max heap, right? So for five, so I'll say that it can be six. Why not? So and if I put a two over here, okay, and this could be any value. Let me put it as zero only. Okay, Afnan?
Yeah, zero works, I think.
Yeah, should work. 0, 10, whatever it is, it's fine. Doesn't matter. But if
That's
you
an
put zero, then there
arbitrary
are so
value.
many things.
Yeah,
Huh?
kind of
Hmm.
simulating the worst case scenario here.
Correct.
Because
Okay, wait a
yeah,
second. I don't need to put a 2 over there. I put 6, just 6. Still, it's fine, right?
yeah, it works.
Hmm. So we need to convert this as a max heap. See, what's the upper bound there? Asking.
So it is about the level, I think, no, because you'll have to at most travel up to the
Hmm.
height, and a height we know that it is going to be login only, and that is why
Yeah.
I think it is O of login only, no, because
Mm-hmm.
you'll have to travel a path basically, right? You kind of keep swapping and swapping until
Hmm.
the position is moved to its correct place. Now,
Correct.
to do that, you'll have to travel a path, right? So to travel a path, the maximum path that you can travel will be of size
Mm-hmm.
log n only, no? Because that's the way binary trees
Yeah.
are structured.
That's correct.
So that is why I
Hmm.
think we are getting a complexity of O of log n. No?
Yeah, yeah. But
That
there's
I think is a
something special. Yeah, something special about this is if you convert this into heap, max heap, so it will be something like I mean, the tree structure will change. You
yeah,
understand how it will change?
but if we could do that step by step, then we will see how much we needed to travel. What were the
So
number of operations that we
how
performed
do
to
I do that?
complete.
How do I do it step by step? Help me here.
Yeah, you can just swap it, no? I mean, one by one to see. So
Okay.
let's say, for example, 0 and we have 6. So 0 needs to. So, okay. So in that case, I think we'll have to compare it with the adjacent nodes
Hmm.
only, no? We have to see
Correct.
whether to go to the left or right. But see,
Mhm.
there's this confusion that I'm having is that they are not saying it's a binary search tree. So we are not assuming anything about the order left or right, right? So how do we
Huh.
know whether to move to right or to left?
Simple. Yeah, that's correct. So simple. But we have to change the structure also. I think, right? Structure also will change.
Structure
Okay.
will change. That is okay.
But order doesn't matter.
Order doesn't matter, that's for sure. But then
Mm-hmm.
which direction to move to, whether to left or to right? How do we know that? That's the question.
So they're asking that after
So
conversion,
binary
it is going to
tree
be
is
max. Balaji, go ahead.
root will be
Balaji.
the lesser than the root. right side will be the greater than the root. So accordingly, but the topmost one, then once again it will start from the heap. So I think it is totally complete binary tree only.
I didn't understand what you were saying. Means how is it relevant to here? I understand your complete binary tree part, but what do you mean, Balaji?
Complete binary tree, what I meant is heap also is a complete binary tree only. So
Yeah, that's
that
okay.
will
I agree with that.
now, except for the topmost that root, we have to compare with the root and the child.
Root and the
So
two
in a binary tree, the child will be left child
in
will
the
be
order.
smaller than the root and right child will be
No, that's for binary search tree, not binary
so.
tree.
But in the maximum,
Balaji, that's for binary search tree,
so
not binary tree. Okay. Balaji, there is a very huge lag in your voice. Afnan, shall we move ahead? Afnan? Yeah, okay. My God, everyone is gone. 324. Okay. Navika, are you here? Anwar,
Yes, I am. Yeah, I'm Gokul. I'm here.
are you okay to continue or you want to take a break? It's been like 2 hours.
It's fine. Like as you say, if you want to take a break, you want to have your lunch, we can just take 20,
No,
30.
I was having in between. Don't worry.
Okay.
Yeah. I mean, if you
Actually,
want, then
these two, three questions are the one even which I'm facing, issue. I had this doubt. I've sent a similar question, like the one which is after this to you on WhatsApp also. So I
yeah,
will
yeah.
take this one.
Then if you have the doubts, then let's discuss those things. That's what is important.
Okay. So even this one, like first, we'll take this up also.
Okay. They're saying that binary min heap made up of 1, 2, 3, 4. Wow. So we have like 5, 12. So minimum value will be at the top.
Right.
So similarly, if you have 2 here, then the minimum value will be at the top always. So the heap is going to build up.
Yes.
Okay. So ideally 3 should go there, something like that. And then 4, 5. Oh, this is how it will be like, huh? I'm not sure. 4, 5, 6, 7, 8,
Yes, you
9.
can have
Okay.
5 over here and then 6, 7.
Yeah.
It's like
6, 7. Still, it's going to be like, okay, 8, 9, 10, 11. This is going to be a min heap, right? Fine.
yes.
14. Yeah, and they are telling that, okay, fine. Assume that each number exactly occurs once in the heap. The depth of the node in the heap is equal to the number of edges. Huh? What does it mean? Depth equal to number of node number of edges to that node from the root node. Okay, fine. So what is depth of 5? Navika, they are saying that depth of a
Depth
node
of
is
5.
nothing but starting from the node, how many edges you have.
Yeah.
1, 2, 3.
3.
So depth of 15 is 3, and this is going to be 2, and this is going to be 1 because 1 edge you have, and the depth of this is going to be 0.
Yes.
So they're talking about depth. Fine. Thus, the root is at depth 0, which we saw just now. So what is the maximum possible depth of node number 6? Sam?
6.
What's the maximum possible depth of node number 6?
Yeah.
Mm-hmm.
Otherwise, it's
Yeah.
coming to be how much? Like
So
2?
ideally they are talking about 1, 2, 3, 4, 5, 6.
Is that a heap?
Okay. Yeah. I mean, this is still a minimum heap, right? So I can have a 7 here. Okay. Right. And then 8, 9, 10, 11. This is still a minimum heap, right? I mean, you can do the other part. So 1, 2, 3, 4, 5 will come like this. Okay. Then the
Okay.
rest of things goes in the order. Other point, they are saying what is the maximum possible? Yeah, Afnan, go ahead.
So,
Afnan, talk.
Yeah, shall I go
Please.
ahead? Yeah, okay. Am I audible
Yeah, you're
clearly?
audible.
Okay, sure. So the question is that in the binary, sorry, in the heap, so there is this condition, no? Whenever we kind of list down the nodes or draw the tree, we'll have to, before moving on to the next level,
Left
we'll
to
have to fill
right.
the previous level.
Ha ha ha. That's right.
So, so that we are not doing here, no?
I'm
So
saying
how
that.
do we?
Yeah, I'm saying that 7. Okay, here comes 8, 9, 10.
So then
No,
the
Okay,
no. But
tenth
here,
one would be six. The tenth, the one where you've written 10 now, that will be node number six then.
are they asking that?
Yeah, because they're saying maximum possible depth of node number six. So one is like 1, 2, 7, 7, 8, 9, 10. So the 10th one would be the no, the ninth one would be the sixth node. Because we'll be reading from left to right each level.
Afran, you want to say something for this?
no, no, that is fine. But my other question was that, whenever a heap is given, so the order is also given, right? So you cannot arbitrarily say that, okay, after one, you're going to put seven here on the right side. No, you'll have to always go on to the order because you're changing the heap that way if you put, in any order. So that we cannot do, right? So I think the
See, they
first one
didn't
that,
say that. They are saying that they are made up of this many numbers.
okay, okay. So it is not necessary that we always take it in
Okay.
order, right?
Now,
It
now,
is,
now, now, come to the argument that how can we say that the answer is 5? Afran, under what
yeah,
instance?
they're
Under what?
asking about, they're
Hmm.
asking about the depth only, no?
They're asking about
Depth.
depth. Yeah, maximum possible depth.
Depth of the node number six. I think, okay, in that case, if they're just saying that this is the set of numbers from where we'll have to pick the numbers and build them in
Mm-hmm.
heap, then in that
Mm-hmm.
case you have the choice to put it anywhere as you wish, right? Because you're doing
Correct.
it, no? That also,
Correct.
that the other one that you have done is also a mini heap, right? So in that
But
case
we
we'll
won't.
just have to see where six can at all go, right? The node number six, what is the maximum possible depth that it can at be, right? So it is at five, no? In that case, because see, five is only possible when you have at the root node zero depth, right? So we have zero depth at one depth at two, two depth at
Hmm.
three, and so on and so forth till at the sixth node. Whenever we are at the sixth node, we have the
Hmm.
depth as five. So five is
Hmm.
the correct answer. So in
Hmm.
that case, it is okay. I was assuming that this itself is a heap. So in that case, we'll have to take it from in the order. But
Hmm.
as you pointed out correctly, that this is just a set from which, using those numbers, the heap will be made later on. So in that case, we
They,
can pick in any order, right? Hmm.
yeah, they played with a curly bracket, man.
Yeah, had it been a square bracket, it would have been a heap, according to the convention. Yeah, yeah, true, true. Sure,
Hmm.
sure. Okay, it is fine then. Yeah, what you have drawn is correct only. So it will be five, right? Sure.
Hmm.
I think it is
No,
clear, at least to me. Yeah.
I still have a
Navika,
doubt.
can
I
you
mean,
answer?
node
Go ahead.
number six is the node number six is the value of the node,
Node
or it is the index.
value.
Okay. So then we can put six anywhere then.
Hmm.
Why only here?
So do you want to put it somewhere down below that, Navika? Do you
Just
want to put
yeah,
the
I'm just
6?
yeah, I'm just wondering, is something of that sort possible?
Is it possible?
I'm not too sure about it.
Because
Because if you
if
have
you
to
want
just
to,
arbitrarily put the values.
so all the minimum numbers, all the numbers that are less than 6 has already been put above that, right? And they said it is a min heap. What does min heap mean? The parent should be lesser than the
Okay.
children.
I understood. I understood now. Yeah. I understood.
So, so is this clear now? How answer is 5, everyone?
Yes, it is.
Great. Balaji, is that fine for you? I don't know if your voice is ready.
So, Gokul, just to add to that previous question, can you
Go
also
ahead.
say in that way? Because, at least for this question, the way the
Hmm?
question is framed. So, can you
Yeah.
also say that there are, because we are having a set. Sorry, could you please, move your cursor so that that set is visible? Yeah, okay, sure. Thank you. So, no, you can see that this is in series, no? 1, 2, 3, 4, 5, 6. So, we can kind of assume that these are numbers, set of numbers from 1 to 512, inclusive, both
Hmm.
endpoints. That
Yeah.
is okay. So in that case, we can also see it like intuitively that okay, this is a set of numbers which is in kind of series. So the all there can only be five numbers which are less than six, no, in this set. So
Mm.
obviously the depth will be five only for six, because there are five other numbers which are smaller than six. And since we are starting for the root node as depth zero, so whatever the total length is, it will just be minus one of that. So it is like five numbers
Yeah.
less than six. Basically, that is what.
Correct.
Yeah. Okay. Understood. Understood.
Fine. Nice. So, Navika, I think you are having doubt on this also, right?
Yeah, like I've just opened the question
Mhm.
paper. I have doubts in almost
Sure, sure. So
50% of
consider
the
a text
questions.
file which has probability of occurrences of seven different characters as followed. Okay, let's say the seven different characters are A, B, C, D, P, and F, and G. Hope I have written seven. Okay. So if Huffman coding is used to compress this file, then what will be the average code length of the character? How do we calculate this? Ah, okay, that's totally okay.
So mm,
Mm-hmm.
like we have three for the first. I'm not remembering. One second. Is there any formula for this, like wherein we multiply, like we have three as the length of the first one, three as the second one? Do we do it that way?
So that's what I'm wondering about. Afnan, do you remember how we did this?
Okay. So they are not specifying the frequency of characters, I think, in that way, because you're not sure about the total length, no? Total length of the text file.
So
Have they have they said anything about the total length of the file? No, no.
no,
Consider
there is
text
no
file.
total length. So in total
Yeah.
length, what you do, you need to multiply that. So here it is not that case. So you just need to find out how many bits will each of these, you know, take, right?
Yeah.
So given
Okay.
the frequencies.
Mhm. Yeah, it is fine. I think we don't need to convert into the actual frequency, right? Given that total is not known,
Yeah,
we can just do it using the frequencies themselves. I'm sorry, the probabilities themselves, right?
correct.
Because they are kind of
But we
acting
need to
as a,
use the algorithm to do that, no? Now in this case.
yeah. So I think the same thing, no? That pick
Mhm.
the minimum most, two minimum most, and then group them together
Exactly.
and add them
Now,
like that.
Navika, do you know how the algorithm works for
We'll
Huffman?
have to build the Huffman tree actually. Yeah.
Correct, exactly. Navika, do you know how to do that?
Yes, I know how to create a Hoffman tree.
How?
Like
Oh,
this question is a bit different to that. Like, but for example, if we are given certain values of number of characters, and then
so
how
I'm,
we
I'm
create a
going to,
Hoffman tree.
yeah, yeah, please. So this is fine now. Still with this also you can create a Huffman tree, right? Want to create one? We
Yeah,
can.
yeah, yeah. Yes.
How do you generally create?
So first we put it in ascending order.
Very good. So is this already in ascending order? Please confirm that. I don't know. It's not in ascending order.
No,
Shall we put this in
no.
ascending order?
Yeah. So it'll be
0.064.
0.030 first. 0.030.
Acha, okay. Hmm. Then 0.076,
6476. Yeah. Okay.
0 point,
Mm, 76, and then we have 169. Huh? All right.
yeah, 1. Mhm.
Then we'll have 2, 0.2, I think. Then after that, 215. Yeah. And 246. Finally, 1, 2, 3, 4, 5, 6, 7. Yeah. Correct. Correct.
Yeah. So we don't even need to give the names. We can directly more and do the other stuff.
It's
Do we
better
need to give them?
to label them also, no? Because, yeah, I understand that it is not
Hmm.
required, but it is better that if you give that, it will be better. Right?
Okay.
Just
Okay.
do
Let me.
ABCD.
Do you want me to give for these? May I give for
Yeah.
these?
Yeah.
Instead of doing like this. Okay.
Yeah. Yeah. You can just, do ABCD directly. It'll be better to kind of group them and all, refer to them. It'll be easier to refer to them.
Sure. Sure.
We'll
Okay.
just say E plus F like that
Ha, 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 ha.
instead of saying this
Okay.
symbols. Yeah.
So
Okay.
merge these two,
Yeah. Okay. Yeah. Okay. So then we'll have to sum them. All
right?
right. What it will be? It will be
Uh,
94. Huh?
9. Yeah.
0.094, which is AB. Yeah.
Hmm.
correct. And under that, you'll have to. Okay, okay. You're doing it directly. Huh? You'll not be building the tree. Huh? Okay, sure.
Yeah, we will build it. I mean, you want me to build it up?
Yeah, it's better to it's better to kind of build it up. Also, no, because you'll have to trace. No, Tom, we need to
Okay, how do you
trace.
want me to do? How do you want me to do? You want me to put the 0 point A here and B here?
Yeah, A here, B here, and each the frequencies, and then we can sum it up. Then yeah,
Okay.
like that,
Hmm.
like that. And okay, after that, what is the next minimum, including the combined one, right?
Yeah.
So in that case, the next two minimum, I think becomes this and this only, no?
This
A,
and this
B,
only.
and
Yeah.
C. Yeah. So
All right.
that will merge. So AB
So
goes with C.
so how do I
ABC
do
will
that?
be like the parent of the whole thing. ABC.
Something like this,
Yeah. And C will be.
right? So this will be C, right? And this will
Yeah.
be A,
Hopefully it
B,
is
C.
correct only.
Huh? Huh? Sorry.
Hopefully it is correct. I think.
Yeah, yeah.
I think it is.
Hey, it can go either in left or right. That's what we
Yeah.
are
Yeah.
trying to.
Yeah. Yeah. That is not a problem. Okay.
Hmm.
Sure. So
So what
have
do
you
we
added
have?
them up for ABC? ABC you'll have to add, no? So 9
Yeah,
4
yeah.
plus 7 6. Okay. Let me bring in my calculator first.
Sorry,
Ah,
one
let
seven, I think. Yeah, it's 1 7.
me
Simple, bro. 6, 6 plus
0.169.
4, 10, 0, 1.
Yeah, yeah. Okay, okay, yeah, sure. So 1
Hmm.
7. Correct. Okay. So that is for ABC. You're not writing that. Okay, anyway. 0.17. Then in that case, minimum becomes 0.169 and 17, I think. Right?
Yeah, these two.
Hmm. That will be ABCD. I think they're only going in the order.
Hmm.
Sometimes it happens that you have to pick up something else, not from the
Yeah, yeah.
immediate.
A, B, C.
Uh,
Fine.
fine.
What do we
Okay.
get? Sum is going to be 17, 17 is P40 and then 0.339.
0.17 plus 0.169. 339. Yeah, correct, correct. You're good at
Okay.
calculations. Okay. Now we
Okay.
have 0.2 and 339, but that will not be the minimum now, right?
Yeah.
So we'll have to pick up
Hmm.
the minimum, which means we'll have to pick E and F, which is 0.2 and 0.215 respectively.
Hmm. So
So
there's
that will
some
give us EF. Yeah. Some will be easy, I think, in this case, at least 415 only.
E and F. I can separate. I should separately add them, right?
Okay, and then
Not
you will
bring to the.
kind of okay, sure, sure. You can finally do that. Anyway, they are going to, you know,
Yeah,
yeah, yeah,
yeah. We can do
sure.
that, right? That's how we need to do.
Okay, sure, sure. So then we'll
Mm-hmm.
have 339, 415, and 246. So among these, 246 and 415 are the two smallest,
Hmm.
right?
So this
So
was
we'll
A.
choose
Yeah.
EFG, I think. Yeah.
Huh? Not AFG, bro. How
Why?
come? Three three
Oh,
nine and two four
sorry,
six.
sorry, 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 sorry. ABCDG.
Yeah. A B C D G. Correct.
Yeah,
So A B
yeah.
C D. I have current G over here. Wait, one second.
Okay, your screen is stuck. So if you're writing something, it is not visible.
It's coming up. It's coming up. Is it coming up?
Yeah, now it is coming up. Yeah,
Okay. So
sure.
A B C D and G is over here, and they sum up to A B C D
D,
G.
yeah,
Hmm. And the total sum for this is, you know,
I
um,
think we do not have anything left off, no? Only
yeah, yeah.
two. But
So okay,
anyway,
remaining. Anyway,
anyway, we'll have to sum up. So it's better to sum. Okay. What is that? Two, four,
why do we need
six.
to sum? Why do we need to sum?
Because we'll do A, B, C, D, E, F, G finally, no? E, F, and
Uh,
that one. We'll have to do.
EFS here. Simply, it's gonna be like this only, no, bro.
Okay, sure, sure. Let's skip that
Huh?
sum for the final one. Yeah, yeah,
Yeah,
yeah.
it's not required anymore. I don't want
Yeah,
it.
I understand. And anyway, I think what I think is that if we sum them, we should be getting a one, no? Given that's the
Ah,
frequency. Yeah,
yes,
should
yes.
be getting a yeah, should be
Hmm.
getting a one. It's better. It's a good idea to sum them up because sometimes it helps you validate also whether you're going to do into the correct direction. But anyway, yeah.
Okay.
So now
Hmm.
what we will do is for each of those characters, we'll just write out the encodings, and then from there we can find out the average bit length, right?
Okay.
Average code length. Sorry, yeah, code
Yeah,
length.
I can write like this, right? Something
Right.
like this, I believe.
Yeah, it is easy also. If you don't write, we know that left, right, left is 0, right is 1, like that. Anyway, you can write it.
Huh?
Yeah.
So
So
should I
1.
write? Is
Yeah,
this
yeah, you
going
should
correct?
write it. Yeah, yeah, you're going correct only. 1, 1. Everything that is to the right will become 1 only. So that is easy. Yeah, everything that is to the
Oh,
left.
that's right. So here 0 will come.
Yeah.
Got to add that 0.
Now, better that we'll have a table and we can
Yeah,
kind
yeah.
of
Now we will draw the table. Yes, correct. So
uh,
let's
the list
start with
basically.
A.
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 Yeah, sure.
Hmm.
For A, the encoding will be, I think, so we'll have to
1.
trace till 0, no? So, okay. So if we go to the left, we'll get EF. So there we'll not go. We'll go to this side. So it will be 1, 0, 0, 0, 0, 0. Okay, sure, sure. Correct.
Is
Okay.
this
Now
even
for B.
correct? I don't know. This is even correct. I don't know.
Should
Let's
be
see.
correct because if if
Let's see.
if the rest of the things had it be, I mean, like, given that the rest of the steps were correct, this should be correct only.
Ah,
It cannot be wrong if
okay.
given the Huffman algorithm, right? So that's the thing. So yeah,
Okay. Got this? Triple zero and 1.
yeah, sure,
You
sure.
should be okay.
Mm-hmm.
Okay. Now
See,
this is correct only.
yeah. Just a second. Just a second.
Go,
Let
go.
me see it once. So I'll just try to trace till C myself.
Yeah,
Okay,
yeah.
once.
Yeah.
Just okay, so we are going to 1, then to 0, and then to 0
Copy.
again, and then from okay, yeah, yeah, 1, 0, 0, 1. True, true.
Go ahead.
Okay, so the only condition in this Huffman encoding regarding the prefix is that the whole thing for a character, right, cannot be a prefix. You cannot start with something which is an encoding for
Yeah.
something else. That is the
Correct.
only constraint that we have, and in this case, I think
Yes.
it is valid only.
Yeah, yeah. It's valid.
ABCDG till DG you have done, so okay.
I was
E
worried when both the numbers came as 5 digits. Then, oh my God, what is this?
Okay.
I
No,
thought
in
like
that
the
case, yeah,
ah,
because finally you'll have to, go till that also. So that will remove the
correct.
ambiguity. Yeah,
So when
that's
we
the idea.
finally come to this, yeah, E is going to be
Correct.
0, 0, and F is going to be
The ambiguity
0
will
and
come
1.
only when assuming a case. I'll just give an example. So if we have something with the encoding 1000, like 1000, right? Then you will not be able to distinguish once you see 1000, whether it is that character, let's say X, or 10001. I mean, like, whether you have to step ahead or take that as a character. That's where the ambiguity arises. So in this case,
Hmm.
it is not the case because the whole thing is not a prefix of something else that is there. So that is the
Hmm.
idea.
Hmm.
Hope it is clear. Yeah. Okay. Sure. So we have EF. I think it is all, no.
Yeah.
So
So simple. Now,
just as a check. So whatever had the highest frequency, I think 0.246, which is E, I think that had the highest frequency, and you can see in this case that E has been assigned the
bro,
lowest.
once again, no, no, no. Yeah, I mean, are we taking? Okay, you're looking at here, bro. This is what we took, not that. Whatever I have written here. Please don't see this. I wrote it as a
Okay,
start.
okay, okay. I took it from there only, but yeah. Anyway, it's fine. So okay, understood. So it is for G in this case. So G also is getting only 2 bit, no 2 bits, encoding. So that is
Hmm.
good. That's a good sign because whatever comes the most number of times, our objective is to assign the
Yeah,
least number of bits to that particular character. So that is
correct.
being satisfied here. So anyway, yeah,
Yes.
okay, it's fine. Now, how do we find the average bit length? It is to is it to sum all
So,
of these and get the average? That's all.
yeah, just tell me the sum. So it's 5 plus 5 plus
5 plus
4
5
plus
plus 4, 2, 3 plus 2 plus 2 plus 2, 3 times.
right total by.
No, no,
My God,
something is
something
wrong.
is
I think. No, no, no. I think we can you just do that again? So 1, 2, 3, 4, 5. 5 plus 5.
5 plus 5
Yeah. Plus
4.
4 plus 3. And are you sure that this is 1 1 only for G? That should be 1 1 only. Yeah. 1 1 only. So it is 2. Something went wrong then.
Yeah, we'll see. Uh, Divide
Plus
by.
2. Why
Okay,
7? Why is it 7?
average length, right?
No, 7 means there are 7 characters. That's why. No?
Correct. 7 characters.
Yeah, yeah. Okay, it's fine, but then it should have been coming out correctly. It is not the case here.
Mm-hmm.
3.28. We must have
Yeah.
done something wrong in this, or it might be the case, although less likely that the answer itself is wrong.
Mm-hmm. So we missed something here. Okay, shall we try the same? Is it possible to put a Huffman, you know, code and fetch out the result? Shall I try to do that? Huffman, which week was that?
Okay, week I'm not able to recall exactly. If you, yeah, just
Either 6 or 7.
you can go to
Yeah, 7.
home actually. You can go to home, and then
Yes,
from
yes.
there you can see it. Okay, yeah, week 7. Yeah, sure. Yeah, we can do that. I mean, you can just. But see, the problem
So,
is that we don't have the characters because we just have the
huh?
frequency.
You see how I'm gonna do that.
Okay, we'll make it
Just
happen.
multiply, na? Just multiply,
Yeah,
na? Multiply by 100 or
that
something.
that many times. Yeah, sure, sure. That we can do. So that
And this is the first time I see a
that
question like
input
this.
and that input that we'll be giving into this character will be like the text file, right? That we are having.
Yeah,
Is that right?
correct. Not text file. I'm gonna make it a string.
No, no, I understand, but in the context of the question, that input will correspond to the text file.
Yes.
Okay, sure, it's fine.
Afman, are you here still?
Yeah, yeah.
So we'll just multiply into 1,000. So A will have 76.
Yeah,
Okay. Uh,
sure.
okay. So we'll take it in the order how we had it. A will have 30. Okay. B will have. Okay. So let's 0.076. Can you just read that?
Yeah, that one.
Questions alone. Yeah.
Question question one. Right.
With
So
the
zero
values.
point zero 0.064,
Hmm.
0.030, 0.169,
Mhm.
0.246, 246. Yeah, 0.2, and then finally we have 0.215. That's all.
Right. So G. Right. I think. Do we have? Okay.
Yeah, yeah.
Great.
Till G.
For I.
Okay, so you're trying to multiply, huh?
Yeah. So is it X sorted or sorted X? Sorted X, right? Sort of X we can give.
Okay. Sorted X, sorted.
Sorted. Sorted X. So basically X will be sorted. So now I'm gonna give. So it should take. Okay. For I in sorted X. So A range. Let me save that also.
Okay, so you're trying to multiply each of these by the frequency. Is that?
Correct. So I need to,
Yeah.
just like how we did there. Probably I don't know if we made a mistake over here. I just wanted to do it everything automated.
Yeah, you
So
can do. Actually,
I'm going to give the values. For A, it should be the lowest, then B should take the next
yeah,
second lowest.
understood. So in
Yeah.
this case, I mean, assuming that the total length for our case is 1000, so the number of times A occurs will be 76 only. No,
Yeah, yeah.
that you can
You're right.
easily do. Can I tell that? How to do that?
Okay.
Yeah, in the string you can do one thing. Remove that thing. That string literal from that A B C
Sure.
D. No, not that. The second line. The next line.
One,
eh,
just one minute.
from L. Yeah. You can sort
Yeah,
it.
I
It's
understand that.
fine.
I understand that. I just sorted.
And then you can take individually and multiply that. That you can do
One
easily.
second, I'll just go inside. 1 second.
Okay, sure.
Yeah, I'm back. Oh my god.
Yeah.
Hello?
So what you can
Ah,
do, there are two changes that you need to do. The first one is that in line number one, so you can just say x is equal to sorted of this list. Okay, that
yeah,
itself,
nice.
right? Right there you can sort it. No, you don't have
Uh-huh.
to do it again.
That's great.
Sorted off this thing. Firstly, second thing is that you can say that print statement. If you wish, you can keep it, or otherwise you can remove it. Anyway,
That's not required.
and
Yeah.
yeah, and L value L, what you can do A, and then A into x of 0 times 1000, right? So you get the point, right? What I'm trying
Yeah.
to say. A into,
Right?
yeah, it is fine. Okay, go ahead. Into sign, that that asterisk or star, whatever that is,
I
star.
have done it. Okay, wait, is it not updating for you?
Okay, no, your screen is stuck actually. Okay,
Yeah, I
sorry.
think so. Yes, my screen is stuck.
Okay, sure. To x of 1 times 1000.
I asked him to, disconnect. So no problem. You can. I mean, this is the last question. We'll take a break after that.
All right, sure.
Just
So
making
maybe
just.
we can take a break and possibly come back half an hour.
Okay. No, I have to go for another session also.
All right. Okay. Seems like you are the mentor for a lot of lot of courses, huh?
I have friends, basically.
Oh, okay, yeah. No, that's good, no? Because end term revisions are going on for every subject.
Hmm.
Right. Okay, yeah. Your screen is, you know,
Something, especially count, multiply, sequence by.
what is that?
Okay.
No, what you have to do, I'll tell you what. that x of 0 into 1000 part, you can put it in brackets because it is not understanding what you're trying to multiply, right? So you will have to first do that. No, no, no. Not there actually. Just from x.
Okay.
From x. That into the outside star is fine. That
Yeah, got the
yeah,
point.
yeah. Got the point. Yeah. This one. That 1000 probably we should have made a constant there. But anyway, yeah, it's fine.
Uh,
It should be
okay.
working, but you have to do it for everything. Huh? That's the point.
Yeah, is this
And
correct?
one more thing is that you're only doing it for x of 0. No, you'll have to update that also. X of 1, x of 2, so on and so forth. Two things. Okay, just getting the text file is being tricky. Maybe I'll write a function that gives us.
That's what I was even trying to do, but yeah, that's okay. We're almost
No,
done
no,
with
no,
this, right?
not about this particular one. Actually, I just thought seeing this that I'll write a routine that will give me any type of Huffman problem, basically a Huffman input of any given frequencies. I'll just write in the frequencies and get the Huffman tree for that. That's
That's
the
what
idea.
even I also will do.
Yeah, yeah. So the last one, I think there is a problem. You have this star inside of the bracket, wherein it should be outside. The last one, the G. Correct that also. Yes, seems fine to me, except for that last one. 6.
6, right?
Yes,
If
should be
I'm
fine.
just hitting the L,
Alright, should be fine. It's saying the can multiply sequence of non-int buff type float. Where does the float coming up? Okay, okay. So that multiplication you're doing with 1000, it is taking it in floats, huh? So you'll have to do int of that also. Okay, this
what
is
do you mean?
becoming. So this part actually, x of 0 into
This is what
1000,
you're
it is,
saying.
yeah, it is doing it in. You'll
This
have
is
to do.
okay. I can just copy paste this.
Okay, easier. Basically, it is saying that a string you cannot multiply it by a float. That's all it
Yeah,
is saying.
damn. I think here's also a mistake.
No, no, that plus is missing basically. Plus after e. Sorry, that is a star. I'm sorry. Yeah, yeah.
So still, I need to complete this. Okay, we
Yeah,
got this
finally
finally.
we got it.
This is easy to copy. Copy.
Okay, so
Just
you
copy.
can just put it in there. Yeah, yeah.
Put this. Run this, and let the computer do. Okay, I think seems like we have.
Yeah, only that left and right part has been changed because we're going to this
Yeah,
is going
that's
to the
okay.
right side, so that is 111. But we have got the same thing, I think, as far as the lengths are concerned. Let's see. 1, 2, 3, 4, 5. Yes. Okay. 5, 5, 4,
Ah,
3, 2, 2, 2. Okay.
then seems okay, right? I mean, that's correct.
Hmm. That's correct. But then what is the average code length? So how do we compute that? Generally, I'm asking. I mean, is that the way to do it? Taking each length and then dividing by the number of characters we have? That is the most likely thing that we need to do.
No, 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 no. Sorry, that's the problem we made. Damn, now I remember.
Okay, 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 okay.
Wait,
Okay,
I'll
sure.
tell you. This is easy. This is easy. Simple.
But
Okay.
at least we were able to verify that our workings were correct, at least to the half tree part. So
Yeah,
that's a
that's
good
correct.
exercise. Yeah.
So simple. Afnan, what I want you to tell me is,
Okay.
tell me the frequency,
All
multiple
right.
frequency and the length of the encoding. So 2 times what is the frequency of f? 2.15. So I mean
Okay.
0.215.
Okay. And then you'll have, okay, okay, okay. No, no, but
That's correct.
it
That's
is
the
about
frequency
the
now.
yeah, but that is about the average frequency and not about the
You,
average
you
code
will get
length.
that. You will get that. You just wait now. You just wait.
Okay,
Follow.
sure.
Follow
Sure,
me.
sure,
So
sure.
what is
Yes.
for E? For E, it is
Two.
length of 2 into
Okay.
frequency of 2.
Frequency of two is what? Sorry, frequency of E is what?
2. See here.
Point two. Point two. Point two.
Oh damn. Please correct me with that.
Point
Okay.
two. Okay. And then we'll have what?
So
Y-
G
You are
is
going.
2
You're going. Okay, you are going in this direction. Okay.
You are the
Okay.
order. Yeah.
2 into 0.246.
Mhm.
Correct. Hmm. Go ahead.
D
Okay.
into or D point 169.
169. Yeah. Okay. Plus
That was D, right? So now C. It is 4
C.
into point 7.
0.0766. Correct. Yeah, we are getting close.
We are getting closer, right? 5 into that's for D 0.064 plus what's this? 5 into point zero 0.03. Boom, boom, boom.
Yeah, yeah, we got it right. Yeah, okay.
Yeah.
Sure. So what we did is basically take the length of the frequency and multiply it also with the frequency. And
Yes,
then
yes.
we'll get that. So okay, I got the point now. What we do
Hmm.
as a last step is divide by the total length. But in this case, since everything is like normalized, given that they are probabilities only, we'll just have to
Yeah,
find out the expected frequency basically.
yeah. This is how we are supposed to do. Oh, that thing was wrong.
Yeah, so in the stats we also do this, no? Expected frequency. So what we do is that x times frequency of x and summation.
Huh.
Discrete
Mhm.
case.
Yeah.
That's okay. Sure, sure.
Okay. So then let's
Okay,
stop
thanks.
this
That
as
was a
of
good
now.
exercise.
This
Yeah,
was a really good exercise.
yeah.
You
Okay,
informed.
so just before closing, which
Yeah.
question number is this? This is 326, huh?
Wait, wait, wait.
326.
Ah, my God.
So it
326 we are completed. So we'll start with 327. I'll just put it in the group.
327 and yeah, okay, sure, sure. All right. Sure. So once you are back, you can just put a message in the group also. Right.
Yeah, sure.
Sure. Okay. All right.
Bye.
So shall I drop off now?
Yeah, yeah, we'll drop off. Bye.
Okay.
Thanks.
Sure. Thank you. Thanks so much. Yeah. Bye.